Hello, welcome to Accounting Hub. I'm Professor George Scarpin, PhD in accounting, and let's talk about linear regression analysis, one of the most important analyses that we have on business stats, business analytics, or any other name that you want to name it. So, what is a regression analysis? It's a statistical method for obtaining the unique estimation equation by minimizing for a set of data points the sum of the square of the estimation error. And an error is a distance measured between the regression line and your data point. And we call it usually the least squares linear regression. That is the most common. So we have two types of variables. The dependent variable is the number to be estimated. For instance, what we will be working later, revenue and advertising expense. The revenue is the dependent variable. This is the number that we want to estimate. Independent variable adds expense is the variables used to estimate the dependent variable. If we are working with only one, add expense and revenue, it is a simple regression model. Two or more, add expense plus number of stores. We are talking about multiple regression model. So here, usually a simple linear equation has only one, so the equation is a plus bx. So that is only one plus error. So here, let's consider supplies expense, production level. So here we have dependent variable, independent variable, and usually we need more than 12 points, 1 year of data. And then here, the regression line and the observations. And then the distance between the observation and the regression line is the error. So the system or the math generates a curve that minimizes this distance. So that is what we do. And then here, if we are working with units sold and costs, so if the A, the intercept, is 220 and B, that is Bx, so B times cost or B times units sold, then our equation would be 220 plus 0.75 times number of units. So that would be the total cost, for instance. So we have some pros and cons. Pros, objective, statistically precise method of estimating future numbers, and provides quantitative measure of its precision, the R-square, the p-value, and so on. Cons can be influenced strongly by outliers data points, or do we need to exclude them or to treat them? So reliability, the t-value and the R-square first, then the t-value and the p-value. R-square for the model as a whole, p-value for each variable, and precision, we have the standard error, or the SE. So the t-value is how good our variable is. So if we can have multi-collinearity, but it's a topic for another video, where two or more independent values are correlated. So they are explaining the same thing. So they are bad numbers or bad variables. So we should remove them. And then the p-value, usually we use p-value less than 5%, just like any hypothesis test. And the standard error is the measure of precision or accuracy. And what do we do with the standard error? That is one standard deviation. So minus or plus one standard error means that 2/3 of our data will be there, 2, 95, 3, 99. So lower standard error is good. And then we usually have two types of regression analysis: time series, one company, long period of time, cross-sectional, a lot of different companies at the same time. And we have panel, then we are not talking about regression, that is time series plus cross-sectional. So, okay, let's go to our data. Let's go to our Excel file. So here, let me put a zoom in. We have some numbers, revenue and add expense. And then we have a summer. Here, we will talk about the summer later. So, okay, from 2 years, and then I want to check if the add expense is related or can explain our revenue. So the revenue is our dependent variable or the y axis. Add expense, the x, or the independent variable or the x axis. So first of all, we can create a scatter plot here and check if the numbers are kind of consistent. So insert scatter plot. So yes, kind of not perfectly, but okay. Maybe we have a good regression line here. So okay, let's keep it here. So how do we perform the regression analysis? Data analysis. However, what if you don't have data analysis? Just go on File, Options. If you have, just skip it. Add-ins, Excel add-ins, go, Analysis Toolpack. So if I come here, it will go out. So Options, Add-ins, go, Analysis Toolpack, and here they are. So data analysis, tons of stats analysis here. So we go to regression. Regression, Y range is our revenue. So we select the name revenue, okay? I will explain later why. Y, the X range, add expense. Labels means the first row is our label. So new worksheet, let's call it revenue and ads. Okay, so here we are. So what do we have here? The variables. So let's go on yellows. R square or the adjusted R square. Usually adjusted R square is more reliable, a little bit lower, but unless you are working with tons of variables, because it's adjusted by the degree of freedom, the numbers will be quite similar. 0.84, usually this number goes from 0, bad model, adds is 0% related to revenue, to 1. That is the 100%. 100% we find only on textbooks, on real life, never. So 84 is quite a good number. We can go just like grading students. So 84 would be a B. So, okay, usually we consider more than 0.7 a good one. Standard error, 133. We will talk about it later. And for our variable, so let me explain it. Add expense, the coefficient is the number that we will go on our equation. And the p-value, forget about p-value of the intercept. It is only calculated, but no meaning. Here, that is our green. E minus 10, so very, very low number. So if we go here on the, whoa, see how small this number is. So less than 5%, so we are good. And then the equation, what is the equation for revenue? So revenue equal to minus 20, 5, 0, 14, 4, 9, 28. So we consider the sign here, plus 85.2456521 times add expense plus or minus our error, our standard error, 1330539.263. So this is our regression equation. So this is our revenue equation for this one. However, we consider that maybe during summer our sales are larger because our product is very good on summer. So we want to add this summer as a categorical variable. However, regression, just like math, we work with numbers. We don't work with yes or no. So when we have a categorical variable, 0 and 1, man, woman, yes, no, Vikings or Packers, if we are talking about Minnesota football, and so on, Brazil, Argentina, if we are talking about soccer. So we can work with them. How? 0 or 1. So we pick one, for instance, 0 for no, 1 for yes. So let's copy and paste these no's. And then here we have one yes, one yes, one yes. So June, July, and August, yes, yes, yes. And then, okay, let's run it again and see if anything changes. So data analysis, regression. The Y range remains the same, but the X, we need to add this summer. So we need to add this and then an adds and summer. And we call it a dummy variable or categorical variable, 0 and 1. Okay, let's see if we are better. 84, 88. So yes, we are better now. Probably. Oh, come on. No. So R square, better. Standard error, also better from 133 to 118. So the add expense. So first the p-value. Good for both. Some are not that good like add expense, but 0.01 is lower than 0.05. And then the coefficients here. Or this one is also a coefficient. So now our formula, let me copy and paste here and only change the numbers. So our formula will be minus 3604259914 plus 82. Delete here. 82.9337455 times add expense plus or minus 1 or no plus 1477051.433 if summer plus or minus 1180868.648. So here we have another number. So if it is during the summer, then our revenue is $1 million more than when it is no summer. So yes, during the summer we sell an average of $1 million more or $1.4 million more. If we have more than one, for instance, summer, spring, fall, and winter, 4 categories, then we need to split it in 3 dummies variables. So 1 is the standard, for instance, summer, and then 1 if it is spring or not, the other one if it's fall or not, and the third one if it is winter or not. And then we can go to a summary. of the two models. So first, rev and adds. The second one, rev and adds and summer. So let's work with the R square. Oops. R square and the standard error. And then we can compare both. And the difference. So here, probably the second model will be better. So here, the R square 84, standard error, and then we can go here on dollar sign because we are talking about revenue. So the first error was $1 million, $1.3 million. The second one, a better, so the closest to 1 is the better. And here, standard error, $160,000 less. So yes, when we add the dummy variable, it begins to get better. And here, that is how we usually test our model. We are adding variables one by one, and then we see if the model is better or worse, and we look at the p-value, and so on. Okay, guys, so this is the basic of linear regression. If you have questions or comments, please leave them here or email me. Thank you so much for watching this video. Have a very nice day and God bless you.